Welcome. Today we'll analyze the physics behind a firefighter spraying water from a fire hose. We'll look at how the water travels in a parabolic path and calculate its maximum height and range. Here's our scenario. A firefighter is spraying water from a fire hose. The water exits the hose at an angle of 135 degrees above the horizontal and reaches a distance of 30 feet. Let's break down the initial velocity into its horizontal and vertical components. The horizontal component will determine how far the water travels, while the vertical component affects how high it goes. We can find these components using trigonometry. The horizontal component is V0 times cosine of 135 degrees. The vertical component is V0 times sine of 135 degrees. The water follows a parabolic path due to the combination of its initial velocity and the constant downward acceleration of gravity. This path is described by two equations. The horizontal position is given by x equals vx times t. The vertical position is given by y equals vy times t minus 1/2 gt squared, where g is the acceleration due to gravity, approximately 32 feet per second squared. To find the maximum height, we need to determine when the vertical velocity becomes 0. The maximum height occurs at this point. We can calculate it using the equation. Hmax equals Vy squared divided by 2g for our case. With the water reaching 30 feet horizontally, we can work backwards to find the initial velocity and then calculate the maximum height. The range of 30 feet is determined by the equation. R equals V0 squared times sine of 2 theta divided by g, where theta is the angle with the horizontal. For 135 degrees, sine of 2 theta is -1, which explains why the water travels in the opposite direction. Given our range of 30 feet, we can solve for the initial velocity. V0 equals the square root of negative r times g. This gives us an initial velocity of approximately 31 feet per second. With this velocity, we can calculate that the maximum height reached by the water is approximately 15 feet. Understanding these physics principles helps firefighters effectively control their water streams to reach different heights and distances as needed in emergency situations.